Welcome to the video for section 2.1. This video we're going to be talking about absolute value functions. This whole second chapter is on absolute value functions and equations. And we're going to start in the first section about how to graph absolute value functions. Now, a couple things I want you to remember. Remember the parent graph that we looked at, f of x equals the absolute value of x. That's the one we looked at on our graphing calculators that time. It was kind of shaped like a V, sort of like this, with this bottom point, which we're going to call in a minute the vertex, V-E-R-T-E-X, I'll write that clearer. At the origin, 0, 0. So this is the parent graph of an absolute value function. Notice it's shaped like a V. I always remember that, V for absolute value. And what I want to do is I want to get a little bit more precise than we got in the last chapter with shifts to try to get a more accurate picture on what the graph of an absolute value function looks like if we're given its equation. So for starters, let's just recall that general form that you looked at in chapter 1. Remember some of these things and what they stand for. So we had that A out in front. That tells us how wider or narrower the graph is compared to the general absolute value of x parent. Remember, h gives us that horizontal shift, either to the right or to the left. And remember, because it's minus h, it's always going to be opposite of what you see. Remember also, k gives me the vertical shift, up or down. And that one is exactly what you would see. And also remember this 1 over b, we talked about this a little bit. This kind of talks about compression horizontally. Not a big deal if you forgot this one. It's really going to come more in handy when we try to write some equations if we're given a graph. Really, just in tandem, the A and the 1 over B, they kind of work hand in hand to stretch out or compress the V. Not a big deal. I just want to work that in because you'll see some problems where there's a 1 over B, where there's a number inside the absolute value symbol. Sometimes you'll see numbers where it's outside. But they kind of work hand in hand in terms of shifting the graph either narrower or wider. So what I want to do now is I want to kind of give you the rules of how we do this. So here's how I graph an absolute value by hand. The first thing I do is I find the new vertex. That new vertex will always be the coordinates h, k. Because remember, the parent graph of just absolute value of x, it has a vertex at 0, 0. So remember what we talked about in the last slide in terms of h shifting the graph left and right. That's going to affect the x-coordinate of the vertex. And then the k shifts the graph up and down. It's going to affect the y-coordinate of the vertex. So once you pull out that h and k, you kind of know where your starting point is, that vertex point. So we'll plot that almost immediately. The next thing we'll do is we'll pick any number smaller than h and stick it in the function and get a y value back. We'll then take that point and plot it on our graph. We'll do the same thing for a number larger than h. We'll pick it, plug it into the function, and plot it. Now we'll have 3 points, and those 3 points we can connect and make a V shape. So let me show you how that's done in practice here. So these are the examples that are in your notes. The first one we have f of x equals 4 times the absolute value of x minus 5 minus 2. Now first we need our vertex. So remember we have our h, we have our k. So the first step is pulling out the vertex. So since we're moving 5 units to the right, because minus 5 means 5 to the right, my x-coordinate will now be at 5. K is negative 2, so now my y-coordinate is down at negative 2. So as we start with our grid, I'm going to try to draw this as straight as I can. Here are our x and y axes. So now at 5, 1, 2, 3, 4, 5, negative 2, I have my vertex, so there's my first point. Now I need to pick something a little bit to the left of 5, so a little bit smaller than 5, and plug it into the function. So why don't I use, I don't know, 3. So we'll do f of 3, and we'll replace the x with 3. And this is going to tell me now what the y-coordinate will be. Okay. Order of operations says we're going to do this absolute value part first. So we'll do 3 minus 5. And remember from Algebra 1 what absolute value does. It makes negatives positive. So the absolute value of 2 becomes 8. Excuse me. The absolute value of negative 2 becomes 2. I got a step ahead of you. 4 times 2 now would be 8. Minus the 2 would be 6. So that means on this graph, I'm going to plot the point 3 for the x, 6 for the y. So I'll go over 3 boxes and up 1, 2, 3, 4, 5, 6. And there's my second point. Now to get a third point, why don't I pick something bigger than the vertex of 5? So why don't I pick, I don't know, 7. So f of 7 will replace x with 7, so 7 minus 5 minus 2. Absolute value of 7 minus 5, well 7 minus 5 is 2. And then remember with absolute values, if it's a positive number inside the absolute value, it still stays positive. So we still have an 8 minus 2. So again, we get 6, so that means that x equals 7, y is going to equal 6. So I'll go over 5, 6, 7 boxes on the x, up 1, 2, 3, 4, 5, 6. And notice now, if I connect these dots, I am going to have my V shape. So there's my graph. Okay, so that is the graph of f of x equals 4, absolute value of x minus 5 minus 2. You could always plug this in your calculator and check to see if it matches the same shape and location. Let's try the next one. All right, this is one of those that has that inside number, so let's just work with it. For starters, we're going to pull out our vertex again. So these are the same two numbers. To get the x-coordinate of the vertex, we take the opposite of what we see. So even though we see plus 3, the x-coordinate will be really at negative 3. And then the y-coordinate is just that outside number. So negative 3 comma 1 will be the vertex for this graph. Let me get my axes. Sorry, I'm having a really hard time drawing straight lines with my tablet tonight. All right, so we'll go to negative 3, negative 1, negative 2, negative 3, up to positive 1. So there's my vertex point. So I'll pick something a little bit bigger than negative 3. Why don't I pick 3? So I got the absolute value of negative 1/2 times 3 plus 3 plus 1. Okay, order of operations, we're going to work inside with this parentheses. So 3 plus 3 is 6. Then we'll do negative 1/2 of 6, that's negative 3. The absolute value of negative 3 is 3, plus 1 is 4. So I'm going to plot the point 3 comma 4. I put the x into the function. I got the y out of 4. So I'll go over 3 boxes this way and up 1, 2, 3, 4. Okay, there's my second point. To get my third point, I'll pick something smaller than negative 3. Why don't I use negative 9? We have the space on the grid here. Notice, there's nothing really magical when I'm doing. I'm picking any numbers I want, okay? As long as one's larger than the x-coordinate of the vertex and one's smaller, you're going to get the right shape, and you plug everything in correctly. So we'll plug in the negative 9. We'll work inside the absolute value. So negative 9 plus 3 is negative 6. Negative 1/2 times negative 6 is 3. The absolute value of 3 is 3, plus 1 is 4. So when I go over to negative 9 now, negative 4, 5, 6, 7, 8, 9, I'm going to go up to 4. 1, 2, 3, 4. And I'm going to connect my dots to make 2 straight lines to get my V. Notice what that 1/2 does. It really stretches it far out, just like the 1/2 would have done if it was in front. Okay, it's really expanding this function. So you kind of expected that from what we did in the last chapter. Okay, so there's that graph for G. Let's look at one more. Okay, now I put the 1/5 out in front and I made it negative 1/5, trying to give you just a variety of different shapes and a variety of different problems. Okay, let me put my axes in. X-axis and y-axis. Okay, again, we want our vertex. So our h is inside, our k is outside. H, it looks like +6, but remember, opposite of what you see. So the x-coordinate will really be -6, but the k is the same. So -6, 4 will be the vertex here. So I'll go over 1, 2, whoop, I'm going the wrong way. 1, 2, 3, 4, 5, -6 here. Up 1, 2, 3, 4 boxes, and I plot that point there. So I'll pick something now a little bit bigger than -6. I am going to pick something that's going to, when I add it to 6, it's going to give me a multiple of 5, and you'll see why in a minute. So I'm going to pick -1. I don't want to have to deal with estimating fractions here. So notice when I make x -1, I'm going to get -1 plus 6 inside, which means -1 plus 6 will be 5 plus 4. The absolute value of 5 is still 5, so I'm going to do -1/5 times 5 plus 4. -1 plus 4 is going to be 3. So I'm going to plot my next point at -1, comma 3, which is right there. Okay, I'll pick something smaller than -6. Let's see, I want something that's going to get us something interesting here. Why don't we pick -11? Okay. You could pick any number. Again, it took me a minute to think about this because I want to pick something that's going to make my graphing a lot easier. And notice what's going to happen when I work through the arithmetic here. -11 plus 6 is -5, which means when I take the absolute value of -5 and multiply it, this should be +5 now here when I take the absolute value of it. So -1/5 times 5. When I multiply that by -1/5, I will get a nice integer, -1. I'll add it to 4, and I get +3. So that means on the graph, there's a point at -11, comma 3, -7, -8, -9, -10, -11, 3. Look what happens here. Again, I have a really stretched out. It's so stretched out, I'm having a hard time drawing it straight on my screen here. And then this way, again, another really straight line. So that's still a V, but it's opened up so wide because of that 1/5. Also notice that it's opening down towards -infinity because of the negative sign that's in front. See, some of these things that you've already seen, we're now getting more detail to them. That's the point of this. We're going deeper and deeper into these functions and how they behave. All right, you have several examples on the notes that I want you to try on your own. Feel free to go back and rewatch any of these videos, problems, or any of these examples if things are unclear. Otherwise, good luck. Thank you for watching. And if you have any questions, feel free to touch base with me in class. Thanks again.